Integer 16 is 16 bytes. So that byte defines how much space it is consuming, right? Where everything goes in a bytes. So I allocate 16 bytes. 16 byte means you can add more data there. The range will be more. If I do 2 bytes integer, 2 byte means it will contain the range will be less, maybe from 0 to, let's say, 500 or 1000. By default, there is only one integer, which is integer 16 and all Python does not have, because Python contains a class. You're just creating the object. Everything is object in Python. You're using the other language. These are the data type. To understand it that way, and in other language, these are the data type. In Python, everything is a class. Everything is an object, right? So you're just creating the object of the class. You're not creating the 2 bytes or 16 byte data type, right? Object means you create the integer object or create any other class object, it will be same. Today and tomorrow we are going to cover two more major concepts of functions, which are advanced function, in which we have closer, decorator, and generator. Right? Once we are done with this, then we move to OOPS concept. OOPS concept is the last part of this Python, and last part of our curriculum. After OOPS concept, like the designing section. In designing, we'll talk about OOPS concept, create file operation, database connection, creating modules, packages, deployment, multi-threading, and right, and that will complete the course. So that's the last part, the last segment of the course. Right, we started with fundamentals and logic building. Now we are into function programming skills. Right, so as part of programming, we have covered function, working of function, types of function, debugging. Debugging I have not shown, right? We have to see debugging also. So we'll see debugging, but after doing all these things, we'll move to the last segment, which is your designing. Let's talk about closure. What do you mean by closure? So closure are the methods, are the functions. These are known as partial function. We know what is a function, we know how to design the function, right? We know that there is a function with the return type, there are function with parameter, right? Closures are the functions which can be executed partially. Now, what do you mean by partially? That means you want to execute one set of logic, but you do not execute it completely. You execute some part of it, and the remaining part execute later. That is the meaning of partial, right? That's what we can do with a closure. So, for an example, if I define a function add and then do a plus b, If I define this function and do a plus b, right? Whenever I call this function, I have to pass both a and b, right? I have to pass both a and b, right? I cannot do that. I pass a now, b I'll pass later. Can that happen? No, right? It will start throwing error. So this is a default function where it takes everything. I cannot pass partially, right? Second use case is, let's say I'm creating a login function where I'm logging in and entering my email ID, and that email ID is verified, right? So the first thing we'll do is we'll verify the email ID, right? We'll verify the email ID, right? Whether the email ID is valid or not. What if you are asking the email ID and user have entered a phone number? So that verification needs to be done, right? So I'll verify the email ID and then I'll log in. Now this two part can I execute partially? Is it possible that I can execute partially? I can, right? I can verify the email ID, keep it, and whenever the user say login, I'll log in, right? Or when, okay, first I should tell you the concept. So this is my default function. Now to create the closure, the first point is it should be a nested function. Closures are always a nested function. Okay. Function inside the function. What happened when we create the nested function in terms of scoping? What we get when you create a nested function, when we create the nested function, then which scope, what happens in terms of scopes? How many scope we have? How many different types of scopes we have? We have done the scoping, right, last time. Now tell me how many different types of scope we have. We have done this, right? We have global,
Three.
local, enclosing, built-in, right? Scopes. So when you create the nested function, then what is the advantage? Which scope you get in nested function? We get the enclosing scope, right? Without nested function, you cannot get the enclosing scope. So closure works on the concept of enclosing scope. So with a nested function, we get the enclosing scope where the inner function can access objects defined in outer function. Okay, we get the enclosing scope. The third point is, which is the important part, inner function always. We should always return the inner function. Inner function should always be returned. Right? Inner function should always get returned. Now, if I want to create a closure for this method addition, what I can do is I can define add pass a here, right? Define inner pass b here, and inside I can do print a plus b. Can I do this? Inside inner, if I call a can be accessible, right? And closing scope, right? And the third point is we should return the inner function. Now we are returning the function, right? Let me call this as a add one to, to make it different, right? We are returning the function now. When I call add pass 3 comma 4, it works, right? When I call add one pass 3, right? What happens? It returns. If it returns, then I should store that, right? What is R? No, what does R contain? What is getting returned? Inner function. So what is R containing? Why B? What you are returning? Inner. Inner will get stored into R. So what is R? R is inner function. You are returning the function, so R will become the function, right? If R is the function, if I pass, do you see any difference in the output? But do you see the difference in the execution? Everything is getting executed here in one shot, and here partially. You first execute this, get the output, and whenever you want to execute the second part, you can use. I can write some logic over here, right? Let's say hello, and here also I can write. Both get executed together, but here what happened? Hello got executed, this function got defined, and then we are returning the function, right? This function is outside. When you call it, now you're able to execute the. So you're breaking down the logic into two parts. The first part gets executed when you call add one function. Second part gets executed when you call inner function. But inner function we are not calling inside the add one function. We are calling from outside. Now the question is, as per the function, once we execute this line, function memory gets removed. If memory is removed, then A should be removed, right? But A does not get removed for inner function. That means enclosing scope never gets removed for the inner function. Enclosing scope will always be there. Even though the outer function execution is completed, enclosing scope will always remain for the inner function. And with that concept, we are able to execute the code partially. Understood? We are able to execute the code partially, right? Can you just write this program and execute?
says box graph, right? Lot of discussion happened around that covariance. So not covariance,
So
but
covariant we have not discussed.
yeah, covariance we have not discussed, but Z score.
Okay. Clear? Now, what are the use case of this closer? See, when you log into any of the website or forgot password, how does the forgot password flow work? You enter your email ID, click on next. It goes to the next screen where you enter the verification code or OTP, right? But from first screen to second screen, what happens? The email ID gets verified, and then one verification mail sent to your email ID. In the second screen, you enter the verification code and then move ahead to reset the password. But in the second screen, there is an option to resend a code, resend button, right? When you click on resend, do you need to pass your email ID again? No, right? That means that is also a closer. That is also a closer, which means you are verifying the email ID and keeping it, and then you are multiple times you are resetting. You are clicking on reset button. Okay? So the logic which you don't want to execute multiple times, right? That can be kept out in the outer function. The logic that can be repeated multiple times, execute multiple times, can be kept inside the inner function, and that's how we can make partial function. If I put both in the same place, then like hello, I don't want to execute hello every time. I want to execute hello only once. But in this case, what happens? I add whatever data I pass, hello will be executed always, right? But in this, if I change the data, see, hello is not a hello got executed only once, and then it is just adding. Something like we have a student with something like this. I'm creating get marks, a method where I'm taking the roll number and subject name. Okay. And based on this roll number, first what I'll do, I'll check, verify if roll number is valid. And in the second screen, I can check get, I can select marks of subject. I can get the marks of the subject, right? Get marks of the subject and let me pass the subject name so that I can go know like this is different. So this two logic I can execute, but whenever I call get marks, I pass the roll number and then what happened? Same roll number you are verifying again and again. Is it required? If you verify once, it should be fine, right? Why we are verifying again? Same logic, why we are executing again and again? It's not required, right? So this can be written in a better manner where I create inner function called subject marks, which takes the subject name, right? Let me pass a roll number also. And then I have to return as per the concept. Get marks roll number 1. It gives RES. What is RES? So if my roll number got verified, RES is nothing but subject marks, which is a function. Now RES is a function. So RES of maths will give me the RES of right. I can have multiple nested function. Now I'm creating two. I can create three, four, five. And if I create three nested function, then it will be in three parts. So you can always break down your logic, right? Again, closure is not mandatory concept. You can do the same thing with a normal function. But in normal function, I can see the same code is like we are bound to execute, right? We are executing it again and again, which is not required. So closure make it much more like more proper design, structured, where only those logic you execute which needs to be executed. If I do not return, then it's not a closure, it will not work. So you have to bring the function outside, right? How to bring? You have to return. And then you can make use of function. The whole idea here is, the whole concept here is that enclosing scope does not gets removed even though you bring the function outside. Enclosing scope will always be there. Clear? Now, if you look at the thing, right, what we are doing is we are passing the input. Logic is same. We are passing different input, right? We are passing different subject name, but logic is same. So you can write one more point. In closure, data is changing, logic is same. So when you have a scenario where you're not changing the logic, but the same logic you are implementing with multiple inputs, multiple data, their closure can be used, right? Like same email ID, but multiple OTP. Same subject name, roll number, same roll number, but multiple subject names. So finding out the logic marks of the subject, that logic will be same, but with different subject name you will be executing that. So their closure can be used. Roll number is enclosing, right? The one which is not in the global, neither in the global nor in the local, is the enclosing. So for subject marks, roll number is the enclosing. Subject name is the local. Clear, right? Now, what is RES? Function. But if I just ask you to substitute, then RES is nothing but you are storing this, right? Into RES. This returns a function, but this you are storing. So if I do this, it will give me the same output. That means now this way, this one and this one, box number 14 and box number 7, box number 820, that's the same thing. So if I want to execute everything in one shot, then this is how we can do in the using the closure. Right? If you want to make it partially, then yeah, you can execute, you can call it separately. But here what we are doing, we are not calling in one parenthesis. We are calling multiple. The first parenthesis is for the outer function. Second parenthesis is for the inner function. Right? So first we are executing the outer function, and that outer function output is getting executed with the inner function. Right? So get marks will give you the subject marks function, and that function again you are executing. So that's how you can do in one shot. Clear? Shall we move ahead? We can't give multiple. That's so. If you want, you can pass this as a list. Then you have to define here. You have to implement a for loop and then execute. Right now we are passing one marks at a time. So if you want, right? But this will not make sense because maths and chemistry. Now this first part I don't want to execute multiple times. So that's where I am saving it. I will execute this once, and then this will I'll just call the second part, right? Clear? There's another concept called generator, right? Now, what a generator in closer, what's happening? We are breaking down the logic into two parts, and the logic is not changing, but the input is changing. You pass multiple inputs to the same logic to get this executed, right? In generator is a kind of loop list. That means you have collection of data storing in the form of a list. So for example, I have list of employees. From that list of employees, I want to get how many employees are staying in Bangalore. So I'll query each and every employee and then get the list, and that list I'll be putting inside the put that list of data I'll be putting inside a collection, right? That collection could be a list collection also. Instead of list collection, we can use a generator. Generator is also an object which contains collection of data similar to list tuple dictionary, right? But generator are faster than list. Okay. How do we create a generator? So suppose I have a function. I'm creating some function show. This one. No, this one you are calling outside, right? This you have defined the function, then you are calling the function. Yeah, it should be same. If you put it inside, then it will not work. This one, it's not going to work. It went inside the function. So how can you call show inside the show? Right? First you have to define the show, right? So define and then call it outside. Here what's happening? We are printing it. I don't want to print. I want to store it. So one way to store it is the list. Right? The other way is put yield and it got stored in the generator. Just with the yield keyword, just with the yield keyword, all the output will be stored in the generator object. Right? How do you get the data from the list object? Loop it. Right? Similar manner, you can loop it for x in show right. Now I can put multiple logic over here. If x modulus 2 equal to 0, print x. Clear? So in this, if you look at this, what is happening? The input is same. Show will always contain the same collection of data. Logic is changing. Here I am printing. Here I am putting some condition and then printing. Inclusive logic was same. Data was changing. In generator, data is same. Logic is changing. Right? So instead of storing into a list, we are storing into a generator. Because what does a list do? List. Now, if you look at the generator, you are not getting the data, right? You have to iterate. In list, when you print the list, you can see all the data. That means list load everything. So if your data contains thousands of items, all the thousands of items will be loaded. And then it will start looping. Memory will be consumed more. In generator, it loads one by one. That's why it is 10 times faster than the list. Now this one, we also have, if I create range, range is also like a generator only, right? Like the way you are calling show, I can also call range for x in range of 10, right? Range is also like a generator. Here also you are calling show, range is coming default. But range also has some logic which is storing into a generator object and then you're using it. Right? So generator are the function that returns collection of item in the form of generator object. And once you get the generator object, then you just need to do the looping. You have to loop it. You have to loop and then get the item and build a logic on top of it. So I have the data of India. Let's say I have all the employees all over India, right? Or I have products. Flipkart has a product across India, sellers. Now Flipkart want to find out how many people are ordering from Bangalore. Flipkart want to find out how many people are ordering from Bangalore. How many people are ordering from Bangalore with in staying in Whitefield? How many people are complaining from Bangalore? How many people are interested in some items from Bangalore? So what is common here? Bangalore is common, right? So instead of for all these use cases, instead of going to the master data, that whole India data again and again and then fetching, why can't I filter out, I create a generator which will filter out all the people from Bangalore and store into the generator object that contains only Bangalore people. And then on that, I can implement the logic to find out who is interested, who is ordering, who is not ordering. Multiple logic I can implement in the same, right? So generator is the intermediate collection, kind of filter. You're applying a filter, right, based on some logic. So that instead of storing into a list, we can store into a generator because generator does not load everything. It loads one by one. So it is fast. Clear? For generator, you just need to use yield keyword. Once if you use yield, automatically that function will become a generator function. Everything will get stored into the generator object. Whatever you are yielding, whatever you are passing with yield, that will go to the generator object. And once your generator function is created, then you have to loop and get the output. Right? You have to loop it and retrieve the output the way we are doing here. Right? It's a keyword. Yield is a keyword to differentiate, to identify the generator object. Clear? These two concepts, I'll share the recording. Please go through it. Tomorrow, I think Thursday, right? Tomorrow we have session. So tomorrow we'll discuss again 10 minutes and then we'll continue with decorator. Decorator is also important, right? So this, and then I'll give two assignments tomorrow. Work on it to work. Friday we can start with. Tomorrow we'll also see debugging, right? And then Friday we'll start with OOPS concept that we go for next 10 days, right?